Hey everybody, this is Larry. This is day 17. I forgot to click it. Of the November Leetcode Daily Challenge. Hit the like button, hit the subscribe button, join me in Discord, especially if you like talking about these problems. And let's get started on today's problem, unique path. So, okay, looking at the picture, I have an idea of what it is. Is there any, are there any obstacles? Unique paths, okay. So this should be something like this. Right, let's give it a spin. Show off failed. Let's see. So from 1 1 it will be at 1. This, oh no, that's 0 choose 0. So okay, so 1 choose 0, 1 choose 2 choose 0. 3 choose 1, 4 choose 2, 5 choose 3, 6 choose 4, 7 choose 5, 8 choose 6. You can't see me, but I'm clicking on the example. Yeah, so okay. I think I'm just off by 1 or off by 2 or whatever you want to call it. Okay, so that looks good. Let's put in some big cases. Let's see. I guess like 5 maybe. You can't choose like 50 because that would just be over or something like that. But I think this should be okay. Yeah. So let's give it a submit. Oh, apparently I've done this twice before, which is not surprising. Yeah. Cool. So that was me showing off, though a little bit of an issue, but but got it right. So the idea. And I am going to explain it by drawing stuff. Let me bring something up. I'm going to explain what I'm doing, but I'll also explain the actual way to do it. Or like, I mean, this way obviously works, but just like, you know. Okay, just going to copy and paste this thing. Oops. How do I move this? Oh, there we go. How do I make this bigger? Okay, maybe not. Okay, so basically I looked at this, right? And if you have experience, you may... Let me see if I can rotate this for a second. Hang on. Wait, can you see this? Nope. Hang on. Technology. Okay. So yeah, so I brought this onto a paint thingy. Let me see if I can rotate this. At least... I don't think I can rotate this, or at least like I can rotate this in like 90 degrees, but I wanted to rotate this 45 degrees, right? So basically tilt your head a little bit. And this is mad sketch. How do I rotate this a little bit? I should use a different program next time, but yeah, okay. But yeah, the idea is that this is a very common pattern that comes up in a lot of things. It's basically combinations or binomial distribution, or not distribution, binomial numbers, and what's his name? Is it Bernoulli something? There are a lot of names that this goes by, but basically the idea is that okay, if you write it out at the beginning, there's one way to get here, there's one way to get here, one way to get here, and then one way to get here, two way to get here, because there's one way to get from here, and then one way to get from here, right? Maybe I'll draw the arrows the other way, because there's one way to get here and one way to get here, right? And then this is one again, also one way to get here, and of course this is one way to get. Oh no, wait, oops, no. This is 3 ways to get here, and so forth, right? And of course, if you kind of look at it through the diagonals, which let's see, 3, 1. So this is all going to be 1. This is going to be 1, 2, 3, 4, 5, 6, 7. This is going to be 6, 10, 15, 21, 28, right? And of course, that's the answer. Oops, I was looking away and then messed up. But yeah, so looking at this, if you just look at the diagonals, you have 1, 1, 1, 1, 2, 1. I mean, this got cut off, but this would have been 1 here and 1, 4, and you know, you see the symmetry and all that good stuff. But you know, but yeah, so this, of course, is just from experience. You can figure it out yourself if you really kind of just figure it out. But this is just from experience of me looking at it and kind of show off a little bit. Though I did have a little bit off by 1 because I wasn't sure. Yeah, I mean, I think I was just off by 1 a little bit because I guess this is because I guess I was converting it from 1 index to 0 index. So I think if you think about it that way, then actually it's just m plus n choose m. Yeah. And that's pretty much the idea behind how I did this one. Let's go back. I guess let me move this actually, because it used to be that this was in the middle, but now, well, not that you need to see the code that much, but yeah. So that's basically the explanation. What's the complexity? I actually don't know the complexity of this per se, because you're using a library, and of course the library has its own thing. I actually don't know how the Python combination thing works in terms of complexity. So let's see, what's the time complexity? They claim it is 2 to the n, which makes sense, but I don't know, because you can think about this as you know, I mean, there are a lot of different properties, of course, but you can think about this as m plus n minus 2 factorial over m factorial, or m minus 1 factorial, right? So you have this property, and of course you can cancel out a lot of the left side, and then you can do the product of all these other numbers and so forth. I mean, you know, so you can do this in linear time per se, even though technically that's not quite right, in the sense that these are big numbers you can get into. So the comparison is a little bit weird. So okay, so that's the way that I would do it on this one. Did I always submit it? I always submitted, right? Yeah. Okay. Yeah. Hope this makes sense, but let's going back to the diagram for just a second. If we look at this diagram, notice how I drew the arrows of going, okay, you know, this, for example, this number, this, let me change the color real quick. The 6 is a 6 because there's 3 ways to come from the left and 3 ways to come from the right? So if you think about that through, there is a way, the way that I would solve it without this funky thing is with dynamic programming. Let's see if I did it that way. Yeah, so I did it with dynamic programming last time, a year and 4 months ago. I figured I would. I actually don't know. I could have gone either way, I guess. But yeah, this is exactly what the drawing suggests. So the sum of every cell is equal to the sum of the previous 2. And of course, if you know binomial numbers, you know, this is also a known thing, if you know. So I said, so yeah, so this is something that a lot of people know just from practice, but I would say you can derive everything from scratch. It's not that big of a deal. Let me know what you think. Hit the like button, hit the subscribe button, join me on Discord. I'll see you later. Stay good, stay healthy, to good mental health, and take care. Bye-bye.